With Visual Components OLP, we can test the reachability of each weld beforehand. And we will not lose production time for nothing. Before we did it with the teach pendant, and the whole programming process was done in the robot cell, and we lost several months worth of production time. The Sandvik Turku plant is the key manufacturing site within Sandvik Mining and Rock Solutions load and haul division, producing underground mining loaders and trucks since the early 1980s. Our machines must fit in narrow tunnels, but still be able to lift heavy loads. This means that our frame plates are very thick. A single front frame can consume over 100 kilos worth of welding wire. With most of our welds are multi-pass, which means that each frame has several hundreds of welding beads that need to be programmed. And we also want to weld in TA position whenever we can. We currently have IGM robots and Jaskova robots with MAC welding equipment. Most of our robots also have 10 or more axes. We only weld heavy parts. Programming these hard-to-reach areas would take a lot of time using pendant. We wanted to increase the automation level of our welded assemblies, and this we can achieve with Visual Components. With offline programming, it is possible to program more complex welds from places that seemed unreachable before, and you are able to standardize the torch position along the welds. So with Visual Components, we can check if we are able to weld something, and if we succeed, then we just put it in the robot and we can increase the automation level. Offline programming makes it much easier to plan the welding sequences and manufacturing order. If we do objects that are quite similar, we can replicate the programs in a way that when there's only a small amount of details that change, we can change those in Visual Components. It's really fast because we can do it in a modular way. When I have to do a multi-pass weld, I can just copy-paste from the library we have used. And also the quality will be good every time because we don't have the inaccuracy of the teach pendant use. Currently, we use the Visual Components OLP to program all of our complex welding assemblies, but we also use it to plan welding jigs and attachments beforehand. We got a jig that gave us reachability and optimal welding positions. When we build a new robot cell, we are able to do the ramp-up process much faster with Visual Components. In the future, we want to give our designers better feedback about weldability and reachability of the frames. We want to do it much earlier in the designing process than we have done before. And this way we could further increase the level of automation in our production.